Bismillahirrahmanirrahim. Assalamu alaikum students. This is your 9th lecture of physics for 10th class. In this lecture we are going to discuss unit number 11, that is sound. Once again we are going to discuss the exercise of 11th chapter. In this we are going to discuss multiple choice question and conceptual questions of chapter number 11. Multiple choice questions. Choose the correct answers from the following choices. Number 1. Which is an example of longitudinal wave? Sound wave, light wave, radio wave, water wave. And the right answer is sound wave. How does sound travel from its source to your ear? Options are by changing in air pressure, by vibration in the wires or strings, by electromagnetic waves, by infrared waves. And the right answer is by changes in air pressure. Next one is, which form of energy is sound? Electrical, mechanical, thermal, and chemical. And the right answer is mechanical. Number 4. Astronauts in space need to communicate with each other by radio links because number 1. Sound waves travel very slowly in space. Sound waves travel very fast in space. Sound waves cannot travel in space. Sound waves have low frequency in space, and the right option is sound waves cannot travel in space. Number 5. The loudness of a sound is most closely related to its frequency, period, wavelength, and amplitude. And the right answer is amplitude. Number 6. For a normal person, audible frequency range for sound wave lie between 10 Hz to 10 kHz or 20 Hz to 20 kHz, 25 Hz to 25 kHz, and 30 Hz to 30 kHz. And the right answer is 20 Hz to 20 kHz. Now the last one is, when the frequency of a sound wave is increased, which of the following will decrease? Number 1. Wavelength, period, and amplitude. And the options are wavelength only, amplitude only, wavelength and period only, wavelength and amplitude only. And the right answer is 1 and 2, that is wavelength and period. Now your conceptual questions. The first one is, why two tin cans with a stretched string between them would be better way to communicate than merely shouting through the air? Speed of sound in solid is 15 times greater than the speed of sound in air. That is why two tin cans with a string stretched between them would be better way to communicate than merely shouting through air. Second short question. We can recognize persons speaking with the same loudness from their voice. How can this possible? This can be possible due to different qualities of their sounds. We can recognize a person speaking with the same loudness from their voices due to the quality of their sound, which is defined as the characteristic of sound by which we can distinguish between two sounds of same loudness and pitch is called quality of sound. Now the next one is, you can listen to your friend around a corner but you cannot watch him or her. Why? This is because of the reason the wavelength of the sound wave is much greater as compared to the wavelength of the light. So the diffraction process is much prominent and we can listen the person around the corner easily as compared to we can see him. As you can know that sound is a form of wave, so it exhibits all the wave properties. As the wavelength of the sound wave is greater than the light, so the sound wave can easily diffract around the corners and we can hear him or her. Whereas the light wave have smaller wavelength, so they are not diffract around the corners. They can only diffract through very small holes. The next one is, why must the volume of a stereo in a room with wall-to-wall carpet be tuned higher than a room with a wooden floor? Because room with the wall-to-wall carpet have soft and porous material which absorbs the sound waves, and we have to tune the volume higher. Whereas a wooden floor reflects the sound waves, so we don't need a higher volume in the room with a wooden floor. The volume of a stereo in a room with the wall-to-wall carpet be tuned higher because carpets are soft and porous materials, so they absorbs the maximum sound waves. So that is why we have to increase the volume. Whereas in a room with a wooden floor, maximum sound waves reflects, so we have to lower the volume. Now the next question is, a student says that the two terms speed and frequency of the wave refer to the same thing. What is your response? Now this is not the case. Speed and frequency are entirely two different terms. As we know that speed is defined as the distance covered by unit time is called speed. It is denoted by V. Its formula is V is equals to S by T, where V is the speed, S is the distance, and T is the time taken by the object. And its SI units is meter per second. Whereas for frequency is defined as the number of waves passing through a point in 1 second is called frequency. It is denoted by F, small f, and its formula is F is equals to 1 by T, where capital T represents the time period. Its SI unit is Hertz. So this shows that speed and frequency are entirely two different terms. Now the next question is, two people are listening to the same music at the same distance. They disagree on its loudness. Explain how this could be happen. This can be happen because loudness also depends upon the physical condition of the ear. Two people are listening to the same music at the same distance can disagree on its loudness. When two people are listening to the same music at the same distance, they disagree on its loudness because loudness also depends upon the physical condition of the ear of the listener. A sound appears louder to a person with sensitive ears than to a person with the defective ear. Next. Is there any difference between echo and reflection of sound? Explain. Yes, there is a difference between echo and reflection of sound. Reflection can occur at any distance. There is no boundary for reflection of sound, no conditions are there. But when we talk about echo, then there must be some boundaries for echo, that the time interval or the time span must be 0.1 second, and the distance between the source of sound and the hurdle must be of 17 meters. Yes, there is a difference between echo or reflection of sound. The reflection can take place at any distance from the denser medium at any time, whereas echo can be heard after 0.1 seconds when distance between the listener and the reflecting surface is 17 meters. Will two separate dB sounds together constitute a 100 dB sound? Explain. Yes, this can be happened if two identical coherent waves interfere with one another, then they can constitute a 100 dB sound wave. And remember one thing, when they interfere, their interference must be constructive. Yes, when two same sounds of same loudness are coherent, then each of 50 dB sound wave will constitute a 100 dB sound wave. Coherent means those waves which have the same angle, same phase angle, same amplitude. In all manners, their wave speed is same, their wavelength is same, their frequency is same. Two identical waves, when they overlap one another, they constitute a 100 dB sound wave. Now the next one is, which is the last one, why ultrasound is useful in medical field. Basically, ultrasounds are useful in medical field because they are highly energetic, as their wavelength is very small, so they can penetrate into a thicker part as well. So we can use ultrasound in medical field for the diagnosis of different diseases, as well as to identify different tumors and to treat different ailments. Ultrasounds are high frequency, that is more than 20,000 hertz, and it carry more energy than the audible sound. According to the relation V is equals to F lambda, the wavelength of the ultrasound waves are very small. So due to these characteristics, ultrasounds are used in medical field. I hope you will enjoy this lecture. Inshallah, we will meet in the next lecture. Until then, Allah Hafiz.